Still waiting for some of you to clear the stuff off your desk, as you were asked to do. Stuff, notebooks, all that goes on the ground. That, on the ground. Okay? Let me just remind you that we are still in the metric system. We're going to continue this next week. So far we've done measuring length in meters. We've done measuring mass in grams, triple beam balance. And now we've done measuring volume using two different methods, volume by filling, and today, volume by displacement. What are we displacing? What are we displacing, Mitchell? In this lab, what are we displacing? What's the substance we're displacing? You know, there's a reason I picked you at that very moment in time. Water. Yeah, we're displacing water. So we're going to finish this lab that we begin today on Monday. And on Monday, you're also going to have an exam. There is one exam per unit. This will be the exam for the metrics or the processes unit. So that's going to make it kind of important. There may be several quizzes. In this case, there's only one quiz. But there's always going to be one big exam at the end. You want to be prepared for it. I'm going to return to you your metric units and prefixes worksheet at the end of the period. When you come back to your seats, just grab it off of the first seat in your row, and you'll have that to study from. Okay? A lot of the stuff that's on the test is found on the metric units and prefixes. And I never make a mystery about what's going to be on the test or a quiz. In this case, you need to know how to find length by using a ruler. You need to be able to come up with that King Henry died Monday drinking chocolate milk, each of the prefixes and what they stand for. You need to know the numbers that go with each of the prefixes. Okay? 1, 10, 100, 1,000, 0.1, 0.01, 0.001, and so on. And you also need to know how to change from one unit to the next. So this quiz that we're going to do here next is just kind of a warm-up for that exam, that test. If you do poorly on this, let that be a wake-up call and remind you that you're going to need to prepare more for that test on Monday. Okay? After we do that, then we're going to get into measuring density, which is measuring length, mass, volume, and density is our fourth thing there. And then we're going to learn the Archimedes principle, which is related to density. And then we're going to build some foil boats and have a little building contest here. I think you'll enjoy that activity. That comes up next week. So we've got some fun things to look forward to after that. Then it's into the human anatomy, where you get simply here. It's a little old, I know, but it's some very good skills that you'll learn in that particular unit, and it's probably the hardest thing you'll do all year, and then easy for a while after that. Okay? Now, since this is our first quiz, I need to point out a few things to you. It's also going to be a first exam on where the same rules will apply. Make sure your name, date, and period are in the upper right-hand corner. This is going to have 13 questions, so you can go ahead and number off 1 through 13 on the left-hand side. It's going to be very, very short answers. And when we take a quiz or a test in here, the following rules always apply. Number 1, no communication of any kind. Okay? And number 2, eyes on your own paper. I don't know, by the way, in the future, let's not use pink paper in here. Okay? This is not the place to express your creativity. You can do that in your class. I didn't mean that as a plan. Ooh. Okay? Number 1, eyes on your own paper. Number 2, no communication of any kind. So, there's no reason for you to be looking anywhere but your paper and up there. No matter how attractive you might think the person sitting next to you is, your eyes should stay on your paper or up here. Okay? If you're looking over there, I'm going to assume it's to get answers. Okay? When I say no communication of any kind, notice I didn't say no talking. Talking is one way to communicate. There are many other ways to communicate. A, B, C, D. Okay? True. False. You get my meaning? Okay? Lots of ways that you can communicate with someone else. Sign language, Morse code by tapping your pen or pencil. That's why when we take quizzes and tests in here, it is stone silent, and people are focused on what they're doing, and there's none of that extra stuff. Okay? Lots of different tricks people use to cheat. I'm aware of most of it, including some higher tech ones like using your cell phone on Viber. I'll say more about that. Head up, please. Okay? So those are our rules for the quiz or the test. And any questions before we get into it? All right. We're going to do this together. We're going to go through each question together so you don't have extra time. Shouldn't be necessary because you either know it or you don't. You either know what number goes with each prefix or you don't. Sitting and thinking about it isn't going to help it suddenly come to you. Now, with that said, sometimes it is helpful to write things, on the test when you get it. Like, let's say, for instance, you remember the King Henry thing. You might want to write that out on your paper. Some people did that on their quiz last period. They wrote out the King Henry thing because they're easily confused. And then they wrote out the numbers. They know that kilo means 1,000, so they wrote 1,000 next to that and filled in the rest of the numbers. Then they had that on their paper. That's not cheating because you recreated it from your memory. They had that on their paper to refer to as they're answering the questions. Because sometimes it's easy for some of you to picture it in your head. For others, we need it written down. Even if we have it memorized, we need it written down so we can actually see it. Particularly when you're doing things like changing from kilometers to decameters or something like that. You can see it and you know how many jumps to make. So that might not be a bad idea for some of you. It's particularly useful to you when you're test anxious. You know how you're going to get your paper taken up and given a 0, aren't you? It's going to be hard for you. Okay, paper, we're up here. Okay, we haven't started yet, but I'm just saying, if you're looking around a lot, it's going to be hard. Make sure you keep your eyes on the paper or up here. Okay? If you're test anxious, having that, see what I mean? I'm going to have to move you, aren't I? I can tell. You two are just not going to work together. If you want to stay in those seats, you need to show me that you can stay focused on what you're doing. If you're test anxious, you get distracted real easily. You maybe forget some obvious stuff, but if it's written down in front of you, you're less likely to make that mistake. Okay? Number 1. Milla is what number? I'm looking for either a whole number or a decimal. No fractions. Okay? You didn't need to do fixed spaces. It's just a single little answer for each of them. Milla is what number? So just, you don't need to write this down, just what would go in that question mark space. What number? Remember, the metric system, all based on powers of 10, makes our numbers pretty easy to memorize. Number 2, deci. What number or decimal goes with deci? What does that represent? That prefix represent? Number 3, hecto. Again, if you did that King Henry thing along the bottom, you can just write those out. What number goes with hecto? What does it sound like? Number 4, a decagram is how many grams? Again, you don't need to write the grams part, just the number. It goes there. What does the deca represent? It's the number. Number 5, kiloliter. How many liters? Number 6, 0.01 of a liter would be called a what? I'm looking for the whole thing, like centimeter. That would be the whole thing. I've got the prefix, centa, and I've got meter is the base. So if I was writing this out, what would it be? I need the prefix part and I need the base part, all written out. Number 7, 0.1 of a gram is called a what? Again, write it all out. Prefix goes with 0.1, and then put the base units at the end. Number 8, the height of your desktop. So from the ground to the top of the desktop, it's 72 somethings. Is that 72 millimeters, 72 centimeters, 72 decameters, decimeters, meters? You decide. That's where that metric dance comes in. Picture how big each of those things are. It's 72 of them. And let's just say, you know, if the answer were centimeters, for instance, maybe you can't picture 72 centimeters, so you turn it into maybe meters. And you picture that. If that sounds right, then you know what your answer is. Number 9, width of a pencil. When I'm talking about the width of the pencil, what I mean is the thickness this way. Okay, that would be the width, about that much. 6 what? What's the latest? Millimeters, centimeters, decimeters, hectometers, whatever. Yes. What did you think we were doing? I know the number that goes with mill. Number 2, I know the number that goes with decimal. Number 10, width of this classroom. Talked about that a number of times. This classroom is 1 what? 1 decimeter, decameter, hectometer, millimeter, centimeter, kilometer. What's the label? You can either write it all out or you can abbreviate it. Either way. Okay. Number 11, the height of this classroom. Floor to ceiling is roughly what? 6 meters, 30 decimeters, or 3 hectometers. Now I know you can all picture 6 meters. 3 hectometers. Hopefully you can picture that. Long or short distance. B, 30 decimeters. Maybe you can't picture decimeters, so turn it into something you can picture, like meters, for instance. If you do that, one of these is going to be obviously the right answer. One is too big, the other one is way too big, and one of them is just right. Okay. Number 12, the diameter of a compact disc. So here's a compact disc. The diameter would be this dimension, that far, okay? Is that going to be A, 50 millimeters, B, 2.5 centimeters, or C, 1.2 decimeters? Okay, please give me the letter answer, A, B, or C. Again, if you can't picture 50 millimeters, turn it into centimeters. Does that sound right? Now, none of these are like way out of whack. These all tend to be closer, but one of them is clearly the closest. Last one, number 13, the perimeter of this classroom, the distance around the outside walls. You can just trace the walls. Now, if you're not good at estimating, I can tell you that this dimension is about 10 meters right here, so the roof's not quite square. That might help you out. So one of them you can obviously throw out right off the bat. Another one you should also be able to throw out because it's way, way too big. And the third one, maybe you can't tell because you can't picture that. So it might be helpful to turn it into something you can picture, like meters. So A, B, or C is your answer. Everybody's done. No? 2 seconds. Let me know when you're done. This is a self-assessment, so I'm going to let you grade your own paper. I trust that you will be fair and honest on this and won't go back and write the answers down. Okay? Number 1 should have been 0.001. Number 2 is 0.1. Number 3, 100. 4 is 10. 5 is 1,000. Okay? 6 is milliliter. and you should have written it out in order to get it correct. Milliliter, not milligrams, millimeters, milliliter. Number 7, decigram. Number 8, centimeter. Number 9, millimeter. 10, decameter, D-A-M. If you put D-K-M, that is wrong. Yes?
Little kids, we didn't abbreviate for 8, 9, 10.
That's fine. Yeah, these didn't have to be abbreviated. These should have been written out. Number 11B, 12C, and 13A. Remember for these, if you just remember that pattern, 1,000, 100, 10, 1, 0.1, 0.01, 0.001, and so you got that pattern there. It's easy to remember what goes with what. It just goes with the King Henry thing. There's no talking here, okay? The last 3 are usually the hardest one, and let me just walk you through one of these as an example. Perimeter of this classroom, 10 meters. I told you outright, this is 10 meters. That's only one wall. So, just roughly in meters, if one wall is 10, the room is 40, roughly. That's not exact, because this is obviously longer than this. So there is no 40 meters up here. 1 hectometer is how many meters? 100 meters. No way this is 100 meters all the way around. So these two are out. 4.4 decameters is hard for me to picture. Now I know where decameters is on that King Henry thing, and I know to go from decameters to meters, I need to move the decimal which way? One place to the right. Well, that comes out to 44 meters. 12 meters, 12 meters, 10 meters, 10 meters, there you go, 44. So that's why that's the right answer. So just do a quick process of elimination, you can do that as long as you know how to change units. If you don't, it's going to be difficult. How many got 100% on it? Good. If you didn't get 100%, you need to spend some serious time going through this. Okay? If you did, don't think that you're, don't have to study it all, because you're still going to have to convert units more, which you didn't have to really do much here. And you're also going to have to be able to use the ruler. Okay? Go ahead and pass those up. Make sure your score out of 13 is on there. Okay, that's not an invitation to talk. You're going to waste time if you guys talk now. I'm going to start getting right into the next piece. We're going to find volume by displacement. Mitchell, what are we displacing again? Water. And we're also going to use another method. We're going to use math to find the volume. Send them on down now. This one takes longer than the other lab. We're going to start it today. We're going to finish it tomorrow after you're done with your test. So you're going to need to manage your time well on this one. I know it's frustrating for some of you working in your groups. Maybe not everybody is contributing. Maybe they're slowing you down. Be assertive. Take over. Say, I hope that pencil mark disappears. Say, I'd like to measure this one. Or if it's still a problem, you can always just do it yourself. You don't have to share with them. Okay? You can be your own little independent group. But there are 2 different kinds of volume measurements on here. If you look at that middle column, that's the one by displacement. That is the one where you're going to use the displacement jars. These guys here. Okay? You're going to use the water method. A lot of people managed to forget that from yesterday, so I'm going to review real quick. Let me just show you what I saw one group doing. Let's say they were finding the volume of this rock. This is what they did. Stop me when I do something wrong, okay? Stop.
Stop.
Yeah, this is what I saw. They started with the container empty, they put the rock in there, and they started doing this. And I told them, I said, well, what do you think you're actually measuring? Nothing. The whole point of this is called volume by displacement. It means that we have to displace something. We're not displacing anything. The rock's already in there. In order for this to work, we have to fill the container up first. Stop me when I do something wrong, okay? Fill the container up first. I've done something wrong already?
No.
Stop me when I do something wrong, okay? Stop. Ah, what am I doing wrong?
You didn't do the finger
I didn't do the finger thing. What's the finger thing, Andrew?
You break the water.
Yeah, you got to break that surface tension. This is not level. These have all gotten warped now from all the water that's spilled on. Anyway, so I come over here and I break that surface tension until what? Until I see air. The tube has to have air along its entire length. And there comes that little air bubble. Boom. Okay. And I look in there and it's clear. There is water on the bottom, but it's clear through the tube. That means that this has now been calibrated. This is the equivalent, I'm going to move this back here where it's more level. This is the equivalent of taking the triple beam balance and setting it to 0. You have to do that every time before you measure one of these. Okay? So that middle column, the one that says volume by displacement, you're always doing this way. Okay? Remember too that when you select the object and you put it in there, that it has to be completely below the drain tube. Okay? This is the bottom of the drain tube. It has to be completely below it. You want to use the container closest in size, but make sure it's completely below that. By the way, I have to say this. This would be the green rock. This would be the white rock. And this would be the black rock. I actually have people ask me that every period. Which rock is this? These are called obsidian. They're a volcanic rock. When the lava cools very quickly, it becomes glassy like this. All right. So that's how we do that. Now, this is calibrated, ready to go. The next step, tell me when I do something wrong. What's wrong? I have water already in the measuring cup. What I want to capture here now is the water that this rock displaces. Or put another way, what I'm really after is if I could melt this down and put it in here, then I could just measure it off. I can't melt it down, not at least in this class. So instead, I'm going to displace an equal amount of water that's equal in size to this. And I'm going to capture it in here. So I got to make sure that's empty. I put it in slowly so that I don't splash. I don't stick my fingers in there. And then it drains out, stops dripping, and then I go to put it in here. Yeah, that's not right. I skipped a step. I have to come back here and I've got to bleed it off again. Got to get it right back to the same point that I started. So all that extra that's being held in there by the surface tension, I bleed off until I see that air in the tube. Now, this would be the equivalent of that rock if we melted it down. I pour it in here, and that should be the volume of the rock. Now, you might say, well, couldn't I just let it go in the tube directly? Sure, you could do that, if you know it's all going to fit, okay, and be below the 100 milliliter line. That yellow block, the big one, block A, will not fit. So you want to make sure you capture it in here. But you're fine capturing it in here otherwise. There's a simple way for these guys. Do you have to use the displacement jar for these?
No.
Well, you do. Well, before you put it in the tube, put some water in there. Make sure the water is, well, I just threw that out as an example yesterday. The water is above the height of the object. Exactly. Then I put it in there and I put it in there and not do what I just did. I think I tip it like that, let it slide in slowly. Head up, please. And you look at how much the water level goes up. Okay? So that's volume by displacement, using the water. And we can do that for all objects, and you're required to do it for all objects. But you also have to do a different method for the regular objects. Which of these up here are considered to be regular objects? Brianna? Just the blocks? Okay. The cylinders are also regular objects. Now you're not required to find the volume of these. What is going on?
I hate stuff much here.
You're not required to find the volume of these using math. But you can. Any geometric shape is going to have a math formula that allows me to measure its volume. Okay? So you can find the volume of those using that. And that brings me to our next piece here. And this stuff up here on the board. Okay? if I were finding the volume of an object like I am over there using liquid, I can measure that volume in milliliters. This is how many milliliters? No. 1. It's actually a bit more than 1. But this is 1 milliliter. Okay? So if I took this 1 milliliter and I poured it into teeny tiny little ice cube trays, my ice cubes that would come out would be this size. Okay? So now instead of being a liquid, it's a solid, like these objects up here. If I wanted to find the volume of this, well, I could do the same thing. I could put it in water, but I'm not going to. Because it's a nice little cube, I can find the volume, the three-dimensional area, if you will, using a ruler. Rulers don't measure in milliliters, they measure in millimeters and centimeters, this particular one. What do you think the dimensions are of all three sides of this cube? 1 centimeter. You got it. This is a centimeter by a centimeter by a centimeter. Basically the thickness of your pinky. Yeah, your pinky's a bit more, but it's a close approximation. Okay? So if I take my ruler and I measure, each side is 1 centimeter. Each dimension is 1 centimeter. One other name we might give this is a centimeter cubed. CM with a little 3 up there. Okay? Centimeter cubed. Why a little 3? Well, I took 3 measurements to get it. Centimeter by centimeter by centimeter. What do you do with those 3 measurements when you're doing the volume of a cube? Add, subtract, divide, or multiply? You multiply. It's right on your worksheet there, guys. You multiply, okay? A cubic centimeter is sometimes written as this. Sometimes it's written as cc. C for cubic, C for centimeter. Cubic centimeter. On medical shows, you hear it as cc all the time. Guy comes in with a heart attack, they say, give him 10 cc's of epinephrine. That doesn't mean they take 10 little blocks of these and get a rubber mallet and pound it into his chest. Okay? That means 10 of these. 10 cc's is the same as 10 milliliters. Remember? This was a little ice cube, same amount of space. Okay? So a milliliter and a cc are the same thing. With that said, if you're measuring liquid, I want the label to be ml, if that's the label on these tubes. If you're measuring using math, a ruler, I want the label to be centimeters cubed. You can see it's already provided there. Centimeters by centimeters by centimeters. And then you're going to multiply them together. Now, a lot of people ask me, well, which sides do I measure? I don't know which 3 to measure. Pick a side, any side. Pick a corner. You take a corner like this. There are 3 edges that come together. 1, 2, 3. All come to that one point. Measure those 3 in centimeters. So if you get like 4.2, 4.2, 4.2, which you might if it is a perfect cube, then what do you do with those 3? No, you don't add them. Multiply them. And then after you multiply them, then you can round it off to a whole number. First multiply them together, then round it off to a whole number. Do not round it off before that. Yes?
So we can do that to all the ones that are even?
Yeah, A, B, and C, and D. Now D is a little bit trickier because it actually is like 3 different blocks stuck together. Treat this as 1. This is the second one. Do you see that? And then a little piece in here. So that means you're going to have to find 3 different measurements on this one piece. Length, width, and height. Okay? You multiply those together, get an answer. Write it down. Let's say it's 5. This one I'm just going to tell you is going to be the same as this one. So you got 5, you write down the other answer, 5. And then you do this one. It comes out to be 2.5. What's your answer? 12.5. You have 3 different volumes. The volume of this, the volume of this, and the volume of this. You find those and you add them together. It's the only time you're going to add them. Okay? Because the volume of this and the volume of this together are what they are individually. Okay? You just add them up. Alright. Last thing to tell you about, and that is, this was an important thing by the way, I hope you got that. That a cc is the same as a cubic centimeter. Good break. Good break. No? Okay. It's the same thing as a cubic centimeter, is the same thing as a milliliter. Okay? There are these two cylinders and this ball that you can find the volume of using math. Which method do you think is going to be more accurate? Displacement or math? Math. If you're good at measuring and multiplying, you might want to take a calculator with you to your station, by the way. If you're good at that, the math one's going to be better. So like on that first one, if the math one gives you 125 centimeters cubed, and the liquid one gives you 100, you might want to go back and redo the liquid one. It's probably, your math one's probably going to be more accurate. But you can check your answers on the golf ball and these two cylinders using my formula there. All you have to do is find the radius and the height of the cylinder. I have these little guys here that help you out. Okay? Is that the radius?
No.
What is that?
Diameter.
Diameter. That's the diameter. The radius would be, look, this is 2, the radius is 1. 2 centimeters, so the radius is 1. If the radius is 1, okay, what's the radius squared? 1. And what's this number? 3.14. So we go 3.14 times 1. You got this in your head?
Yeah.
Okay. And then we find the height. Let's just say the height is 2 centimeters. What's the answer? 6.28. That's 3.14 times 2. Okay? So it's really not that hard for cylinders. For a sphere, I kind of simplified the formula. The formula is 4/3 pi r cubed. I just did all this math for you, and it's 4.187 times r cubed. So I take this. Diameter is 4, let's say. Okay? What's the radius? 2. What's 2 cubed? Please stop that. What's 2 cubed? That would be 2 times 2 times 2. 2 times 2 is? 4 times 2 is? 8. Okay? So that would be 8 times this number. Get it?
Yeah.
So you can do that. That's optional. You're not required to do that. My goal is that you get about 5 or more of these, maybe 7 of these done today. Okay? Any questions? Let's go.